Now we're going to take a proof for horizontal flipping and why it works the way that it does. Again, suppose p of x is the parent graph and f of x is the transformed graph, such that p of negative x equals f of x. In other words, we're going to put a negative 1 in front of our x values for our parent function. I like to always bring up the graph. So for example, with our square root function, so p of x would be square root of x, and our transformed function would be square root of negative x. Okay, so we want to prove in general, though, that there's going to be a horizontal flip and what to do with our original x values in order to get our new x values that will ensure the same y values. Again, we're doing this because we want to graph function transformations. It's the easiest way to do this. So we want to find a value for x2, our new x values plugged into our transformed function, so that p of x1 equals f of x2. In other words, we want to take the same original x values from our parent function and find some new x value that gives us the same y value for both p and f. By substitution, we know that f of x2 is equal to p of negative x2 based on this definition right here. We're replacing x with x2 basically. And then we know that if the inputs are the same, we're going to get the same y value back. So we're going to set x1 equal to negative x2. This will ensure that we get the same y values back, the same y value of the parent function. So you could say the p value. So now we have x1 equals negative x2. There's only one algebraic step to do here, which is to divide by negative 1, which is the gist of the horizontal flip. Just take your original x values and divide by negative 1. Or multiply by negative 1, same thing. So x1 divided by negative 1 is equal to x2. And therefore, we can actually just, if we want to simplify it even further, we can put this negative out front and say that negative x1 equals x2. So what does this ultimately tell us? So when negative x1 equals x2, okay, we can replace, first of all, this is what we were given, p of negative x equals f of x. We can replace x with x2, right? And we know that x2 is equal to negative x1, so we can do another substitution. And double negative equals positive right here. Negatives cancel, so this proves that this will give us p of x1 equals f of x2. In other words, it will give us the same y values, given that x1 was our original x values and x2 are our new ones. And how do they relate to each other? Well, that's when we make the original x values negative, or we just flip the signs. That will give us the new x2 values that ensure we keep the same y value as required. Here's what it looks like on the chart. P of x equals square root of x. Again, we want to use these four numbers because they're perfect squares. Square root of 0 is 0, square root of 9 is 3, so on and so forth. Now all we're going to do now, just like we did in the last lesson for horizontal shifting, if our transformed function is the square root of negative x, just take your parent function x values and divide them by negative 1, and we know for a fact that we will remain with the same y values of 0, 1, 2, and 3. 0 divided by negative 1 is 0. It's not going to flip the sign, but the other x values will flip. And now here is our new chart. Notice again, only the x values change when we're talking about horizontal flipping. The x values all change signs except for 0 to maintain the same y value. And again, here's what that looks like on the graph. Here are our original x values, 0, 1, 2, 3, and 4. I'm sorry, 0, 1, 4, and 9. And our new x values are 0, negative 1, negative 4, and negative 9, and they all give us the exact same y values. That is the gist of horizontal flipping. If you have any other questions about this lesson, let me know.